Okay, so let's start our discussion about the two-way frequency table. So when we are talking about two-way frequency table, we have two type of data that we can have based on the information or the given set of information that we have. The two type of data that we can have for the frequency table is the numerical and the categorical data. Think you are already familiar what is a numerical data and categorical data. When we say numerical data, that is a data that can be placed on a numerical scale and compared from the root word number. So that the data that you have is more on numbers or the frequency table that you will be having. When you say categorical data, categorical data are the data that can be grouped into categories or sectors. Okay. Example of a categorical data, just like the eye color, hair color, the favorite and flavor. So those are the two types of data that we may encounter in a frequency table. We have the numerical and the categorical data. Since we have the frequency, when we say two frequency table or frequency distribution, that is a table that displays categorical data by representing the number of occurrences for two variables. So when we have two-way frequency table, it includes the categorical data, and also your numerical data. The numerical data stands on how many the categorical is being occurred in the set of data that we have. Okay. We have the marginal frequency distribution. This marginal frequency distribution is a table that displays the total of the frequencies of the rows or columns. Since we have two basic um, type of frequency table, the ordinary or the basic two-way frequency table, and we have the marginal frequency distribution. In a two-way frequency table, there is no total, there is no column or a row for a total number of that date set of data that we have. While in the marginal frequency distribution, there's a row and a column for the total number of set of data that we have. For example, we have this data that we have collected. For example, the data was collected from 100 men and 100 women about their favorite DC comic book superheroes, which is the Wonder Woman, Batman, or Superman. Okay. So this is the categorical data that we have. Okay. And the problem or the stated problem that we have on the screen, the categorical data is the male and the female or the gender of the two variables that we have in the problem, which is the 100 men and 100 women. And also the categorical data that we have is the favorite superhero that they want. So if we're going to place this data that we have gathered or collected from 100 men and 100 women into two-way frequency table, for example, this one, for example, that is the collected response from their favorite superheroes. From male and female, we have 25 and 62 for Wonder Woman. For Batman, we have 40 and 23. For Superman, we have 35 and 15. Okay. So here in this data, it's being displayed in the marginal frequency. This one that we have on the screen is just a two-way frequency. But this one is an example of the marginal frequency table. Okay, as you can see in these two different tables that we have, the first one doesn't have a total number, both from the row and column of the set of data that we have. For the marginal frequency distribution, there are total number on rows and total numbers for column. So that's the difference between the two-way frequency table and the marginal frequency distribution. So we have the types of frequency based on that example. We have four types of frequency that we can solve using the two-way frequency table, which is what we call the joint frequency. When we say joint frequency, that is the data within the body of a two-way table, which is this one, the yellow color in the frequency table that we have. This is your joint frequency, the yellow color. The second type of frequency that we can have in our two-way table is the marginal frequency. Marginal frequency is the row total and the column totals, which is the color blue in the table that we have. So that is your joint frequency and your marginal frequency. Using the joint frequency and the marginal frequency, we can calculate or solve the two conditional relative frequency. When we say conditional relative frequency, this will be in a percent form. Okay. That's the type of an answer or a solution that we can have using the joint frequency and the marginal frequency. The other one is what we call the joint relative frequency. The joint relative frequency will be also into percent. So how do we solve for the conditional relative frequency and joint relative frequency? So let's start with the conditional. Conditional relative frequency shows the ratio of percent of occurrences of a category compared to the total of the category, ratio of the joint frequency, and the relative marginal frequency. So when we are solving for the conditional relative frequency, we're just going to divide the cell total by the row total. So for example, if we're going to find the conditional relative frequency of male from the data that we have from Wonder Woman, which is 25, so you're just going to divide the cell total, which is 25, divided by the total number of row, which is 100. So 25 divided by 100 is equal to 25. Or 0.25. Since when we are talking about conditional relative frequency, we are dealing with percent. So since our answer is 0.25, so the conditional relative frequency of male with a response of 25 is 25%. That's our relative conditional relative frequency table. For 62 female that responses for Wonder Woman, we have 62%. Since we have the same total number in the row, which is 100 also. 62 plus 23 plus 15 is equal to 100. So for 40, for Batman divided by 100, we have 40%. We have 23%. We have 35%. We have 15%. Okay. So that is the conditional relative frequency table that we're going to have based from the data that we have. As you can see, you're just getting the percentage. If your total is 100, But if the total is not 100, of course, you will be having different percentage. For example, the set of data that we have, let's say we have this set of data. For example, we have the same categories, but with a different occurrences. Let's say for male, we have 20. Let's see here, it's 50. And this one is 10. This one is... Right. So the total number in a row for male is 80. So if that is the total number for row for the male responses for their favorite superheroes, we will be having a different conditional relative frequency and getting the quotient and the percentage of 20 in the 80 total number that we have. So if we're going to convert this two-way frequency that we have into conditional relative frequency, so if we have 20, so 20 divided by 80 in percentage is equal to 25%. The same, 50 divided by 80. So we will be having 63%. Then the last one, we have 10 divided by 80 is equal to 13%. So that's how we solve for the conditional relative frequency. You're just dividing the occurrences of the data that we have by the total number in a row. Okay, in the given categories. For male, you're going to divide it according to the male total. For female, you're going to divide each occurrences by the total number of responses for female. Okay, so that's how we solve for conditional relative frequency. So what are the use of this conditional frequency? Okay. So conditional relative frequency, these are the types of questions that can be answered from conditional frequency tables. Okay. What percent of males prefer Batman? What percent of females prefer Superman? What percent of males surveyed prefer Wonder Woman? A questions cannot answer from this table is what percent of the total people surveyed were women who like Wonder Woman. So if that is the questions that you're going to answer, okay, using the frequency table that we have, you are going to use the joint frequency. Okay. We're not going to use the conditional relative frequency. Wherein, in solving for the joint frequency, the joint relative frequency shows the ratio of percent of occurrences compared to the grand total number of occurrences. So how do we solve for the joint relative frequency? In solving for the joint relative frequency, you're just going to divide the cell total by the grand total. So solving for joint relative frequency, cell total divided by the grand total that we have. This is our grand total. The total in column and in row. Okay, which is 200. So we're just going to 25 divided by 200. Okay. In percentage, we will be having 13%. So 40 divided by the grand total that we have, which is 200. So 40 divided by 200, which is equal to 20%. Next, we have 35 divided by 200, which is equal to 18%. Then 100 divided by 200, since our total here is 100, so we will be having 50%. Okay, so the same of what we did with the female category, that is also what we're going to do with the female, to change the two-way frequency into joint relative frequency table, which is 62 divided by the grand total, which is 200. So in percentage, we have 62 divided 200, which is equal to 31%. 23 divided by 200, which is equal to 12%. Then 15 divide 200, which is also equal to 8%. And 100 divided by 200 is equal to 50%. So the same, we're also going to get the joint relative frequency of every total category that you have, which is 87 divided by 200, which is equal to 44%. 63 divided by 200 is equal to 32%. And we have 50 divided by 200, which is equal to 25%. And 200 divided by 200 is equal to 100%. So that's how we solve for the joint relative frequency. You're dividing the cell total divided by the grand total, while the conditional frequency, the one that you were dividing, for conditional frequency, cell total divided by the row total. Okay. Your row total is this one. Yung nakalagay dito is your row total. Okay. It's the difference between your conditional frequency and your joint relative frequency. Okay, let's have an example wherein we're going to get the conditional frequency and the joint relative frequency of our table. Okay. For example, the set of data that we have collected is based on the eye color of a student for a male and a female student. So normal color of eye is black and brown. That's the common color of the eyes. So let's say we have for male, the number of student who has a color of black for their eye is, for female we have 25, and for brown color we have 13, and we have 25. So the total number that we have 50 for total number of per row. 37 plus 13 is equal to 50, and total per column we have 37 plus 25, which is equal to 62. 13 plus 25 we have 38. So grand total we have 100. That's the grand total that we have. So 50 plus 50 is equal to 100, and 62 plus 38 is also equal to 100. So if we're going to make a conditional frequency table, we're just going to divide the cell number by the row total. So 37 divided by 50 in percentage, we will be having 74%. So 74% for 37 black, for 13 brown, 13 divided by 50, which is 26%. 25 divided by 50 is equal to 50%. The same 50% also. So that is for black and brown. So 62 divided by 50 in percentage, we will be having 'So that is for our conditional frequency based on the occurrences for the responses of the color of the eye for male and female, which is color black and color brown. If we're going to have the joint frequency, what we're going to divide is the grand total. So 37 divided by 100 is equal to 37%. 13 divided by 100 is equal to 13%. 25 divided by 100, we have 25%, and 25%. So that's how we solve for the joint frequency and the conditional relative frequency. Question about the joint relative frequency and the conditional relative frequency. Wala na. Okay. Yes, Gabby? You have something to say?
I should know.
Again?
I should know.
None. So let's go to your discovery education for the frequency, two-way frequency table.